Hi everyone! In this video we will solve a ticket or stamp word problem. One afternoon, the amusement park sold 789 tickets for $16,240. Child tickets cost $17 each and adult tickets cost $28 each. How many of each kind of ticket were sold? We have two unknowns, the number of children's tickets and the number of adult tickets. I'm going to use the variables C and A to represent the number of children's tickets and the number of adult tickets. If we multiply the number of tickets by the value of the ticket, the number of the tickets times the value of the ticket, and then add those together, we'll get the total. And this is our first equation. So we have the value 17 times the number C, number of children's tickets, times the value of the adult tickets, 28, times the number of adult tickets, A, we'll get the total of $16,240. This is similar to the coin word problems. However, we're missing the second sentence that we can translate for the second equation. But we were told one more piece of information, that there was a total of 789 tickets sold. So this gives us an implied equation. The equation is the number of children's tickets plus the number of adult tickets equals a total of 789 total tickets. And similar to our coin word problems, now that we have two equations, we can solve for one of the variables. However, the second equation isn't solved for a variable so that we can substitute it in. So we can remedy that by solving for one of those variables, and we can easily do this by subtracting A from both sides, which leaves just one variable C on the left side, giving us 789, subtract A, and now we can substitute this in for every C in the first equation. So we get 17 times C, which we are substituting 789 minus A, plus 28A equals 16,240. Now we have one equation with one variable, and we can work towards isolating that variable by simplifying the left side of the equation. Using the distributive property, 17 times 789 gives us 13,413. 17 times A is 17A, and we have plus 28A, which equaled the total of 16,240. Now we can combine like terms. So we have 13,413 minus 17A plus 28A is positive 11A equals 16,240. I've run out of room again, so we'll come up here and rewrite the equation. 13,413 plus 11A equals 16,240. Now we can isolate the variable by subtracting 13,413 from both sides. On the left side, we're left with 11A, and on the right side, we'll subtract that in my calculator, which gives us 2,827. To continue isolating the variable, we'll divide both sides by 11, and we're left with A equals 257. So 257 adult tickets were sold at the amusement park. We can use this information and substitute it back into one of the original equations to solve for the number of children's tickets. I'm going to go ahead and do the second equation because we already went through a lot of work to solve for C. So we have C equals 789 minus A. We'll substitute 257 in for A. So we get C equals 789 minus 257, giving us the number of children's tickets to be 532. So we have 257 adult tickets and 532 children tickets sold at the amusement park, and now we're all done.